Hi, 7th grade. Today we want to talk about factoring quantities out of expressions, but we want to first warm up with just a couple of basic GCF factorizing problems.
Okay, so this first problem here, we want to fully factorize each expression, and the first step is always to find the highest common factor, or greatest common factor. So remember that we need to look at each term separately. We have 3 terms here, and we want to see if they have a number in common, the highest common factor of the numbers, and also we want to look at the variables as well. Okay, so our 3 numbers we have are 2, 8, and 14. The highest common factor of those 3 numbers is 2. So that's part of our HCF. And now we look at our variables. We have an x in the first term, a y only in the second term, and no variable at all in the third term. So that means that the HCF is just 2. They don't have any variables in common. Okay, so to factorize, we're going to divide each term by that HCF that we just found. Okay, so the HCF comes out in front. That's what we're dividing out. Then we have our brackets, and now we're going to put the result of our division. So 2x divided by 2 is just x. Those 2's cancel. 8y divided by 2 is 4, so we have minus 4y. And then 14 divided by 2 is 7, so plus 7. Okay, and remember, you can always check your answer by distributing that 2 back in and make sure you get what you started with. That's to check your answer.
Okay, on the second expression, if we want to fully factorize again, we look for both pieces. We want to look at the coefficient in front and find the HCF of the numerical parts. And we also want to look at the variables and see if there's any variable parts that's in common. So for these two, between 10 and 18, our HCF is 2, but we also have an a and a b that can be divided out from both of those. Remember, this is a to the first and b to the first. So when we divide out 2ab from each of our terms, then what we have left is the piece that gets written inside of our brackets. So here 10 divided by 2 gives us 5. A to the fourth divided by a is a to the third, and b to the third divided by b is b to the second. And then in our second piece, 18 divided by 2 is 9, so we have minus 9. A divided by a is 1, and b divided by b is 1, so we have just 9 remaining.
And to check your answer, as well as distributing, remember to look at what's left inside of the brackets and make sure that there's nothing left in common. So if you look at those 2 terms, 5 and 9 don't have anything in common, and there's no variables in common. So that's how you can know you got the whole HCF.
So what we have different in these problems is that our HCF now is going to be a quantity. It's going to be all of this stuff that's inside of the brackets. We don't want to separate out this r minus s. So the first term that we would look at is 8 times r minus s, and the second is s times r minus s. If this was a problem that said 8a plus SA, then we know that our HCF would be A, and that would leave behind an 8 plus S. So it gets treated the same way, that this HCF that we have is this whole quantity R minus F. So our HCF is, R minus S. So I'm going to put that here in brackets, R minus S, and then we want to say what's left from each of our terms. So if I divide out r minus s from the first term, then it leaves a quantity of 8. And in the second one, r minus s, and that leaves plus s.
Okay, so this next one, we want to look at what the HCF is. And we see that 5 and 2, those are our coefficients. The HCF for those is just 1, so we don't have anything there to divide out. But they both have a quantity of p plus q in common. So our HCF is the quantity of p plus q in brackets. So that comes out in front. That's our HCF, and we're going to divide each term by that and see what happens. So the p plus q's are going to cancel, leaving us with 5 minus 2. Should we leave our answer like that?
Well, if we have any math that we can actually go through and do inside of the brackets, then we can simplify it more. We can't add p plus q because we don't know what those stand for, but we know what 5 minus 2 equals. So we can say that that piece equals 3, but even then, what could we do to make that better, Miss Conley? Do you always write your your coefficients in the back?
Oh no, let's put it in front. It's a bit clearer. And we only need that one set of brackets. So after our first step, we look at what's in the brackets. We had that 5 minus 2. We have to see if there's any like terms left there, and those were like terms because they're just both constants.
Okay, and then our last one here, we see it's a little bit different because we have 3 terms. All 3 of them have a quantity, an HCF of m minus n, and then the 3 pieces that get left behind, when we divide this out, m minus n, m minus n, and m minus n. The biggest common mistake that we see here is that we forget that this is a coefficient of 1. Any amount divided by itself equals 1. And then here we have plus 3 and then these cancel and we have minus n for the last one. Do you have any tricks, Miss Conley, for making sure that you got all of the coefficients, all of the terms?
Well, the original expression had 3 terms, so when you divide by the HCF, each one of those terms should have a result, so you should be left with 3 terms in the bracket. So if you forgot that 1, then you would have only had 2 terms there. But now we have to look at what's in the brackets and see that there's some like terms we can combine, the 1 and the 3.
So that leaves us with m minus n times 4 minus n.